All right, hey everyone. Today we're going to walk through some strategies for building the best user interfaces for developers. We'll pay special attention to font choices and color schemes. Wait a minute. I think this isn't the right audience for this version of the talk. OK, all right, that looks a little bit better. My name's Ty, and I've been working on mobile developer platforms and products for many years at companies like Twitter and Uber. And sometimes those developer customers have been external customers, like when I was working on Fabric, and sometimes they've been internal customers, like a team at another big company that just needs to use my tools. Now, either way, with both of those customer sets, I'm going to walk you through some ways of thinking about building great libraries and tools for mobile developers in general, and try to help bridge that gap between those of you coming from the consumer world to start thinking about developer products. Today, the content will be pretty high level. And it'll be more broadly applicable to developer tools in general, both platforms, iOS and Android. But when I dig into specific examples, especially technical issues that we're going to discuss, it'll mostly be using Android as the domain, with a special focus on some open source runtime libraries that we've built at Uber. So today I'll be covering a few large categories that should give you some insight into how to think about this space. First, we'll discuss how to think about product concerns for developers. And then we'll walk through what usability means for libraries, SDKs, and other tools. We'll move on to important quality standards that will impact your customers' customers, being that's the developers' customers. And then we'll cover some tips for guiding you through having a good release process that the developers can trust. And then finally, I'll walk you through some tips on how to think about engaging your community of customers. So let's begin with the first area to think about when building a developer product. Product ideation, customers, research, and the process. So many of us have built apps for consumers before, but building for developers requires a different mindset and a different approach. A good product abstracts the complexities for the expected level of adoption for your customer base. But when creating professional products, like developer tools, those abstractions start to look a little bit different. And you need to explicitly account for these a bit more, and for your different types of users. So you'll strive for things like consistency, simplicity, and an intuitive UI, but the expected mental overhead of your customer is going to be a lot different than when you're working on a consumer product where you may have an audience that isn't as technically adept. Instead, your consumers will be primarily focused on execution and results. And you should try to align your product goals to ensure their success. Now, in short, your priorities should be similar to consumer products, but executed differently, focusing mostly on efficiency and accounting for a much higher mental threshold in your customer base. In a more traditional consumer product workflow, you may have a product lead that envisions an idea, and they do some market research, and then they work with the UX researcher and designer to prototype it. Maybe they work with the technical lead for some technical scoping, and once there's confidence in detail, it would be handed off to the engineering team. And in that standard world, where there is this expected level of abstraction between the customer and the engineer, the product design and engineering lead's jobs is literally to bridge that gap of the expectations and the customer requirements to the technical implementations. Now, while the developers may not have as much need in general for customer context here. So in short, while it's not ideal, it's not a hard requirement that your development team actually has much customer empathy, as long as the product team does. But it's quite a different dynamic when the customer is the developer, where a normal abstraction would be expected between the customer requirements for a product and the developers. Now the developers are building for other developers directly. So why do we need product roles at all in this world where it's just engineers building for other engineers? And in my mind, there are two major reasons that speak strongly to the need for product roles in developer products. Now, a developer who is constantly context switching between product strategy, market research, building the actual tools, customer engagement to get feedback on GitHub or wherever, they're going to be pulled really thin, and they're not going to get a lot of time to be productive. Now, while your developers will probably take a much stronger role in the product process when they are building for other developers, because they will feel expertise in the system, they still need that time to focus on building the important things for your project to be successful. And you need to segment responsibilities appropriately. There's also a cognitive bias called the expertise bias. Now, the more expertise someone has, the harder it is for them to empathize with someone new to the space. Tim Van Dam once gave an excellent demonstration of this problem using the slope of a mountain. From the base of the mountain, the top seems unreachable. But from the top, you tend to forget how hard the climb was after all the fear and sweat and the temptation to give up that you may have experienced along the way. And this can be a large constraint in product design for developer tools. This one can be much less apparent than the other example that I showed, but I think it can be significantly worse. As people grow closer to the product through continued work on it, it's harder and harder for them to put themselves into the shoes of someone that's brand new to the tool. Now, while this isn't exclusively true to developer tools, that's why UX research with new users is pretty common practice, I think it's something that's more often ignored in developer tools, and that becomes much more of an issue. Now, there's a very hard-to-find balance between empowering the power users of your tools and building the railing for onboarding new users, especially as they may have varying levels of domain experience. Now, when building tools, engineers have a strong tendency to project their own experience and knowledge directly onto their imagined customers, quickly adding pitfalls where things may seem trivial to the author, but overly complex to someone new. So, what is product's role in developer tooling? Well, many developer product teams either don't exist, they don't have product managers, sometimes they don't have designers, or they have a reduced number of them per the number of engineers they have on the team. However, I think this is a mistake. I think that to build a successful developer tool, you need to rely pretty heavily on the product roles, although I would recommend that those specific roles on a developer tool should probably be more technically apt than your standard product manager or designer, since they'll have to work to develop more customer empathy with engineers. Now, remember that developers are humans too. They want usability, they want good designs, they want emotional attachment to the tooling that they're using. So let's dig into ways to think about product design for developer tools. My preferred framework for thinking about solving problems for your customers, and especially for developer customers, is called the Jobs to be Done framework. This framework was designed by Clayton Christensen and Scott Anthony in the Harvard Business Review, and it was to address the overall thinking about the main job and the secondary jobs that a customer is trying to accomplish, rather than specific and bounded business metrics. This covers both the logical and the emotional choices that a customer may make. Now, a job here is just shorthand for a customer's real end goal. Now, if you dig into this process, one of the first examples that the authors gave in the white paper is this interesting study on a fast food restaurant that was trying to sell more milkshakes. When they started researching the customers that were buying milkshakes, they realized, surprisingly, that a really large majority of them were buying them first thing in the morning. When they started looking into that further, they found that folks were buying the milkshakes to keep them entertained and busy and engaged while they were commuting in the morning. You know, they might have been sitting in traffic and they wanted something that they could sip on in the car. So the competitors to the milkshake weren't other fast food restaurants. They were other breakfast items that someone might have in the car, like coffee, smoothies, fruit. Now, this insight allowed the company to make some changes to fit that demographic more specifically, like increasing the consistency of their milkshake so that it drank slower, reducing the straw's throughput, or introducing more targeted flavors that were more breakfast-oriented. Now, by targeting the real job of the customer, they were able to make a big improvement and significantly sell more milkshakes. So if we were to look at crash reporting, an example of a developer product, what does the customer want? Do they want to measure their crashes? No, they want their product to be successful. They need stable software to give customers trust in the product and to give their engineers time to build features and new options for the customer rather than spending that time fixing crashes. They need insight into the data around the stability in the crashes so that they can improve that and get to that space. But this is also, having this insight kind of shows you other ideas for product innovation in this space. For example, if they're thinking more about wanting stable software, what other ways could you improve a developer tool in that space? Maybe automatic crash recovery, maybe user feedback tooling, maybe static analysis on buggy code. There's plenty of directions that could be pursued. Now, we've been talking about the developer customer quite broadly, but that's also quite an important thing to quantify when strategizing for developer products. There's quite a difference in the way a student may work with your tool and a senior engineer at Google may work with your tool. And there's also quite a difference in value that those two different developers will bring to your company. Each will have their own priorities and understanding of the broader framework they're working within. Now, these differences in the customer should be identified, measured, and used within your product framework. So by breaking your customers up into logical groups for your product frameworks, you're able to clearly identify how a specific feature will help each of your demographics out and how much time and effort your team should spend on that for the value that it would get back. At Uber, we identified 3 major groupings of developers for our external API: the head, torso, and tail. Now, the head would include large partners that bring really large value and experienced engineers, and they would require a lot of complexity. This was companies like Google and Facebook and Amazon and other big names. And these were usually managed relationships. We had BD folks who had a direct line with them. We had partner engineers who were working with their teams. And these were the smallest percentage of our customers, but brought the largest value. The torso would include your standard mid-sized startup, and these were more often self-serve through the standard support channels, developer docs, and portal. Now, these would have experienced engineers working to bring moderate value with low support requirements, and these companies could eventually turn into head partners. And then finally, we had the tail of developers, which is the largest set of developers that we served, and this includes students, indie developers, small groups, all that sort of demographic. And these are entirely self-serve through the tools and use the standard support channels, and they brought the lowest value. So as we're thinking about new products, understanding the effort to value spend is really important here. Now, in addition to groups by demographics, we create common personas to describe the actual people that we care about and what a feature could target. For example, a startup founder that wants to quickly bootstrap their new company and just wants to integrate very quickly. A student developer who wants their handheld and they're trying to learn. An enterprise developer that has to use significant rigor and go through an internal review process at their company. Or a product manager that doesn't really care about the technical implementation, but just needs a specific feature that tool is going to bring to their product. Now, all these folks would value different things. And some of those would vary from ease of integration to flexibility to feature polish. So creating real personas around these customers ensure that we adhere to the framework for matching jobs to customers. Now, the Mozilla Foundation has done a really good job of creating a public set of developer personas, and I'd recommend taking a look for a more thorough example. You'll notice the link at the bottom here for a lot of these resources. I'm just throwing them at the bottom in the footer, so you can see them there. Besides identifying the customer group, it's incredibly important to get hands-on understanding from your targeted demographics. Now, just like with consumer products, doing hands-on research with your customers is crucial. So when I was at Twitter, we regularly ran UX research sessions with external developers. We'd bring them in, we'd watch them integrate the product and use it, ask them questions about their expectations. We'd use prodding questions that were very open-ended, get feature requests from them, that sort of thing. And then all that information was funneled back to the engineering teams and the product teams so that they could make decisions. Those sessions were also streamed and recorded so the developers could have direct insight into watching people try to integrate against the tool. It was very eye-opening to think something was very trivial or easy and then watch someone struggle with it for 10 minutes. At Uber, my team has many internal developer customers, other teams. So we regularly sit down with them to do requirements gatherings, product reviews, and understand their new needs. And finally, collecting a larger set of data asynchronously will really go a long way in helping you understand your customers even more. We often use surveys, questions, and developer analytics to get at this sort of data. Getting the right data from your customers is crucial to make sure that you're solving the right problems. One potentially hard area to call out for thinking about product on developer products is how to measure the success, or what goals you should be going after. Now, there are 3 high-level goals that I would recommend that you keep in mind to move the needle. That's developer productivity, developer happiness, and developer trust. Clearly, these are more nebulous, and tracking them can be difficult. But productivity creates business value, happiness creates brand ambassadors, and trust creates loyalty and forgiveness when you do make a mistake. Measuring through NPS, research, engagement, UX research, developer analytics, these will all start to give you signals where you can move these. Now, you should be able to envision a developer tool that solves a real problem for customers using input from the engineers on your team, understanding which segment of customers you want to target, and how much value it'll bring understanding the complexities and who needs what in the integration, and how to measure your audience for that feedback. And finally, some North Star goals that you can apply to that. So with that focus on product, let's move on to making usable software. Usability is thrown around in the consumer world quite a bit. The app should make sense to the user. Text should be self-explanatory. The design should be accessible. The user flow should be simple, concise, and intuitive. It should be the shortest possible path for the user to accomplish their goal. But what does it mean for a developer tool to be usable? It's very similar conceptually to those goals that I just mentioned. You're just applying it to a different surface area. The surface area should be the concepts in your tool that the developer interacts with directly. Developers are just people, and they prefer usable and well-designed tools as well. And this increases their happiness in their workspace. However, as we talk about different customer personas, it's important to understand how to make it usable for each group in those different personas. Usability in your tools and APIs can make or break the developer experience. It's a serious endeavor when trying to improve our surface area. So let's get into some of the priorities to think about when you're trying to move the needle there. For these examples, we'll be working with one of the libraries built at Uber called Autodispose. It's a library for managing your RxJava subscriptions to prevent them from leaking when you have a lifecycle that kills an activity or a fragment or something that it's bound to. Instead of giving a full overview of the tool, I'm just going to kind of pick and choose some APIs that adhere to the priorities that I want to talk about. So it's important to consider how fast the developer can integrate with your tool into their application. You should strive to allow integration with minimal boilerplate and configuration in minutes, and immediately show them the value that they're getting out of this. This can vary a lot from a small library that's just loading an image that you call on demand to an analytics library that you need to initialize at the app startup, and it's bound to the lifecycle events, and it's uploading stuff to a server. Here's an example taken from the Autodispose library, which is pretty straightforward. You add the Gradle dependency to your build file, and then on your observable, you call one method, the asAutodisposable. That turns this Rx chain into an autodisposable chain, and it manages it all for you. Couldn't be much simpler. The APIs provided should also be simple and concise. The more boilerplate ceremony or reading that's required to understand that API and use it, the worse it's going to be. Google recently sanctioned Kotlin as official language for Android, and while the community momentum existed for this prior to Google announcing that, one of the big reasons that it's had the success on Android is because of the conciseness that it's brought over Java. The primary API for Autodispose is both simple and concise. And the API directly expresses itself that it's converting the chain into an Autodispose chain. The API should be self-explanatory and intuitive. A developer should be able to understand what's going to happen without any surprises, just by looking at the method and the parameters. It shouldn't require a certain ceremony to use it in a certain order for it to be correct. The way it works should be clearly understood without having to dig in or retrain user behavior. Here I show at the top just the vanilla RxJava way of managing subscriptions. You subscribe somewhere when a user does something, and then you have to track that subscription and unsubscribe from it in the destroy event of the Android activity or lifecycle component that you're using. Now, this is prone to error. If you forget that, you might leak it and cause all kinds of issues, or that code may continue running after the user's off the screen. Compared to Autodispose, where we didn't need that separate ceremony of ending it. We just applied that at the beginning, and it was taken care of for us. It's much more intuitive for the end user. Your tools should be both consistent with the platform best practices, as well as within the other APIs of the tool itself. On Android, for example, distribute open source code, deploy to Maven Central, and use the Android frameworks and patterns. Just like a design language exists and is used for each platform so the user doesn't have to relearn different navigation dynamics when they enter each app, you should kind of consider that same model when you're working with tools as well. The APIs should be consistent with each other. Use similar wording and tense so that you don't have to teach different concepts to your developer customer. For example, Autodispose needs to be consistent within its own APIs, within the RxJava ecosystem, within Java's patterns, within Android's patterns, and within Kotlin's patterns. So here's our scope handler interface, which just converts different types of observables that you may pass in. And now we can see consistency in the naming of the APIs, alignment with the RxJava types, the annotation to handle error-prone integration for Java and Android integration as well. Now, you should also be thinking about composition in your public interfaces to avoid leaking implementation details and guaranteeing the end product. For composition in Autodispose, we ensure that all public calls expose interfaces to the developer and avoids having direct classes that are exposed. This helps us, the maintainers, ensure backwards compatibility when we update the API. It also helps developers in testing it because they have this interface they can work with, and it ensures otherwise edge cases related to them directly accessing the underlying RxJava types don't happen. In this example above, I'm showing the subscriber proxy for an observable. Now, you may have seen these return from the previous slide's scoping logic. This proxy wraps the RxJava underlying object and exposes just the subscriber methods to the caller of the API. So that's the only thing that they can interact with. Composition helps to increase the resiliency of your APIs, but there are other ways to do that as well. And in general, your APIs should be resilient, defensive, and safe to use. For example, if a method takes an object parameter, it should either be immutable, a primitive, or it should make a copy to prevent the user from mutating that after it's been handed off to your tool. Data classes and configuration-rich objects should use builders to ensure that they're in a valid state prior to you taking them. The APIs themselves should appropriately hold on to weak references and lifecycle-based Android components properly so it keeps from leaking those. And it should be intelligent around not returning results in the different exit scenarios that it's likely to encounter. And it shouldn't be easy for a developer to do something incorrect with a well-designed API. In this primary method of Autodispose, we're proxying the subscribe method so that the developer never deals with the underlying class. In addition to having resilient APIs and libraries, you should consider where proper flexibility and extension would benefit your customer and allow different customer personas to utilize the different product for their liking. This adheres to the open-closed principle. Open for extension, closed for mutation. It's unlikely you'll cover every use case that's needed by your customers. So by having opinionated extension points, combined with a mindset around how to compose your library in different ways as building blocks, you can enable your developer customers to cover their own use cases without having to fork your library or look at it a competitor. For example, in Autodispose, we have a number of extension points, including using your own custom lifecycle events. You provide your own implementation to use a signal for unsubscriptions based on your app's own creation and termination events. There are many approaches to extensibility that could be useful, from creating separate adapter packages to integrate your library, to providing open classes for extension, to allowing custom code to be executed within the context of your library. Now, another interesting example is is how we use separate packages to adhere to different components that we might want to, and popular frameworks that we might want to interact with. So in Autodispose, we provide extensions for interacting with Kotlin, Android architecture components, RX lifecycle, and many more, and these are all optional. The APIs should be testable by the end user customer. Developers should not test business logic of libraries, but they should be able to test the integration points to make sure they're called correctly. And it needs not to be making real network connections or writing real stuff to disk. That would be a real issue. Think about stubbing, mockability, and the ability to run in a pure JVM environment. Ensure the customer's referencing the interface as opposed to the implementation classes where possible. One approach is to distribute a separate testing library entirely, and that would include tools needed for using the unit test frameworks and interacting with the tool in a controlled manner. With Autodispose as our use case here, there are a couple useful properties for developers to test with. One, as we described, all surface areas that the developer interacts with are interfaces as opposed to implementations, which allows proper stubbing and mockability. Two, and more interestingly, we provide test artifact packages so that the developer can compile those only in the test environment to interact with Autodispose in a test manner. Here, we show a test lifecycle owner that enables a developer to emit fake lifecycle events so that they can ensure that their logic is tested correctly. And when things go wrong, and they will go wrong, the developer should quickly be able to see an issue at its source and be able to troubleshoot and diagnose and debug it. So give appropriate logging from your tool. More importantly, fail at the source when something bad is happening. It may be tempting to try to catch an error and continue, But the developer diagnosing a weird state of the application is going to have a much more difficult time trying to detect something later than if it's a direct crash on a stack trace right at the source. If your tool is completely optional and is crashing, you may choose to gracefully degrade or turn off the tool in production. However, this complexity is rarely worth it. Instead, distribute your binary without obfuscation, so a developer can see clear stack traces, and they can step into the issues when they're needed. In Autodispose, we have a plugin system that's modeled after RxJava's plugin system, so people can customize the behavior of the library. For example, you could use your own handler for the lifecycle issues. Now, for more container-like environments, we allow it to be configured up front and then locked down so that a client couldn't mess with that configuration. Now, if they do lock it down and a client does try to change the configuration after, it's going to throw a hard exception. This is much more easily diagnosed at the time when that exception is being thrown than if it was a no-op that was returned, nothing actually changed, and then the developer was wondering why their method didn't work as they expected. You should have clear, concise documentation, both in the code for the IDE autocompletion, as well as more broad examples and explanations that take a more situational stance in your README and your general developer docs. The Java docs or source docs for whatever platform you're on should be hosted and distributed alongside the binary in Maven Central or where you're hosting them. This will be one of the first entry points for your developer, so be sure it guides them efficiently. Sample code should also be available and distributed alongside the library. It should be concise, and it should limit the complexity so that the users can clearly see how to use your tool without really getting burdened with understanding other concepts. In this snippet taken from Autodispose's sample repo, our onCreate method is doing very little besides the bare necessities to utilize Autodispose. The developer doesn't need to spend time reading the code or understanding other things. They can just focus on how to use Autodispose. Now, it should be clearly commented so that the developer can also see and reference that. Lastly, the code itself in your sample repos should be production quality, because a lot of users will just copy and paste this directly, and it will end up in the wild. All right, that was quite a few code examples to demonstrate API usability. If you follow these, your customers will be off to a great start, but that's not all that's required. Let's move on to talk about quality-oriented properties that you should care about. Besides usability with the software, where we focused on the direct effects of your tool on the developer themselves, there are also a lot of indirect quality issues that can affect your developer or can affect their customer, the end user. So let's follow the principle of healthcare professionals everywhere, and first, let's say we should do no harm to the customer's app. And this needs to be prioritized if you want to make a successful product. The last thing you would want is to create a worse experience for either the developer or their customers. These quality focuses require aligning with your developer to understand what's important for their considerations, for their business metrics, for their development, for the success of their project. The benefit of aligning on these is that you build trust with the customer. So let's dive into a few examples of how to improve these side effects that you put on your customer. Stability should be at the top of your mind when working on a developer tool. Not only will it crash for an end user, erode trust from the developer, it's also much more timely to fix a library bug than a standard app bug. Here, let's consider the timeline of fixing an average issue in an SDK that's being consumed by an app. Even if we discover the issue early and we ship a fix, it could be months before the developer picks that fix up from the library and updates their application to ship with it. Longer still for a review process, potentially, and then it might take a long period of time before the user actually updates to the app, the latest version that has the fix. It's possible for library bugs to live in the wild for months longer than standard app bugs. Similar to the importance of keeping a stable product for the customer, libraries also need to do no harm when it comes to performance. Do everything possible to be as performant as possible. This means using appropriate threading, memory management. Try to take advantage of the existing resources when possible, like thread schedulers and file caches. Run profiling tools during your development and test it on older devices. This is an area that can cause real frustration to your developers and users. You'll more often hear about app size discussed in the context of a problem on Android. However, it's relevant to both platforms in my mind. Devices have limited space. You have constraints around traffic size, cache size, memory size. On older versions of Android, you even have constraints on the method count, because using tools like multidex can slow down startup. All these tools are going to impact real users negatively, and that will be disproportionate on lower-end devices and emerging mobile networks. At Uber last year, we had to get all hands on deck to address an issue in our iOS app. We had just rewritten it in Swift and did a new design that we put out, and we were running up against Apple's over-the-air limit for updates. Many folks spent months investigating very clever ways to lower the binary size. So what does this have to do with a developer tool? Well, if your library is embedded in an app at runtime, it needs to minimize its impact on size. Because when a developer decides to prioritize trimming, one area that's usually looked at pretty early is trimming down third-party dependencies and prioritizing those. And it was definitely a prominent conversation during our time trying to make the iOS app smaller. You don't want your library to be on the chopping block. Unlimited data plans have gone in and out of fashion in many countries, and the cellular chipsets drain a lot of battery when they're in an active state. Did you know that in many emerging markets, people actually pay by the kilobyte for data? And they even read changelogs and app updates to see if it's worth the cost of spending the data to do the update? These are all reasons that you should prioritize batching your requests to avoid keeping the chipset in active or waiting mode. You should be conservative with actually what needs to be sent up and when it needs to be sent. You should use protocols that take advantage of compression over the wire, like gzip or protobuf. Here's a fun example I found of a guy that had a $500 phone bill after Google Plus went a little bit wild and ate 20 gigs of his data one month. Here's another area where it's easy to accidentally bring some pretty bad side effects on your end user, when libraries choose to use additional third-party libraries, and then those are brought transitively back up into the app. Now, when I look at this background, it almost makes me a little bit like nauseous or seasick. That's kind of how I want you to think about bringing in third-party libraries in a tool that you're developing. It's not always feasible to avoid them entirely, but unlike app development, one should be extremely conservative with their choice around pulling in these. Not only will they add to the size of the app, but it's possible for you to introduce a Gradle dependency conflict into their builds, where maybe they had directly declared a dependency on a library on v1, and they were using your library, and you declared a dependency on that same one they were using as v2. Now, Gradle is going to resolve that to the highest. Now, if potentially it didn't break the API, so it still compiled, it could fail at runtime. And if they weren't actively testing this flow, which they may not, why would they expect that to break randomly? Then they could ship that out in the wild, and it could cause real issues for real users. If you keep these overall quality metrics in mind, it'll go a long way towards building developer trust. After ensuring that usability and quality of your tooling, defining a consistent release process that developers can trust is important as well. As we discussed, use the best practices of your platform here. So on Android, deploy a release on GitHub or GitLab, put the binary in Maven Central or JSON, integrate against a public CI system like Travis CI or Circle CI so that you can maintain code quality. So let's dig into some specific concerns around the release process to ensure that you keep the developer trust as high as possible. To maintain that trust, you need to be consistent and communicative in the updates with your tool. So semantic versioning is the idea here, that the major version is reserved for API changes. The minor version is used for features, and the patch version is used to indicate bug fixes. A developer should be able to use their work hours to concentrate on solving real business problems for them, not on reacting to a third-party library's version bump that all of a sudden caused them to have to do a migration because the APIs changed and they had to thrash away from their real work to just update your library. Secondly, developers won't always be updating to the last version. If they find a version that works for them and they've tested against that, they have to spend real time to do that update. So over-communication is required here so that your developer customer can understand the benefits of that version. So we'll discuss that communication here in just a little bit. Make it clear to the developer what has changed in each version. Most do not automatically update, like I said, but instead they watch for relevant fixes in the changelogs. So if you were having a crash and you had forked it and you see that they fixed it in the latest version, or if there was a feature that you really wanted, watching the changelogs might be a reason that they actually update. So make this explicit. and link it to the correct GitHub issue per version so that you have transparency and trackability all the way down to the issue being reported. Inevitably, you'll need to refactor or remove code. And I'd recommend that you pay special attention to thinking around the process of deprecation in general. First, before any work begins, always be really thoughtful about adding new any APIs at all, because you'll be supporting them for as long as possible. An API is like a baby. They're fun to make, but they take 18 years to support. So follow the guidelines we discussed for semantic versioning, so that the developer knows when there is an API-incompatible change and they need to schedule some time to get that fixed. Mark your methods or functionality as deprecated as early as possible, while clearly defining the alternative. Never just remove code without giving your customers a heads up. Make sure that you communicate a clear timeline or version when that code will be removed entirely. Use multiple communication channels, like your blog, your email list, your Twitter, your docs, to repeat this information. People need repetition. And lastly, often you'll need to pair a feature or a desirable change with the deprecation to help incentivize people to update to that version. This photo is a cake for my team when we finished deprecating the old legacy iOS dependency graph in our monorepo. It was chocolate raspberry, and it was delicious. With Kotlin, you can even go one step further. So by making use of the replace with parameter in the deprecated annotation, IntelliJ will actually ask the user if they want a quick fix to this automatically. So they can just press the hotkey, say, yes, replace this for me. It'll even ask them if they want to do it across the entire project. So this really helps with migrations from one deprecated method to a modern version. This example here is taken from one of Autodispose's deprecated methods. Lastly, for every successful project, it's very difficult to scale a team's resources up to meet the desire and the scope of a larger project. You won't be able to run a successful project by yourselves. One way to address this is by building an external community of contributors and helpers and maintainers as early as possible. Engage on the standard platforms directly, like Slack, Stack Overflow, GitHub. Praise and reward external helpful folks through thoughtful words or gifts. Show appreciation. Strive to drive your loyal customers to become ambassadors for your products as well. Not only will this reduce the overhead on your support team and your engineering team, but it'll help create a healthier community in general for an overall better project. Jeremy Mize from XDA gave a great talk last year in London on building open source communities that I'd recommend, and that's linked here at the bottom of the slide. I want to emphasize having a clearly defined support system. Set clear SLA expectations for your customers. Keep the lines of communication open as possible so you're constantly getting the right kind of feedback from your developers to fix and improve your product. It's common for teams to put out products with the intention to maintain it, and then as time goes on and team priorities change and people leave, the products rot in the wild. At Uber, like most big companies, certain projects struggle with this. But it's something we're trying to address actively through more stringently defined owners internally. And this is an actual example taken from one of our repos, although I've anonymized it here. Keep an eye out for this in your project. Silence and issue rot signal to others that the project isn't well maintained. And if they're analyzing your project to see if they should use it, they'll look elsewhere. Set your expectation for public contributors. Call out the expected process in the README. Review the PRs quickly. Be as collaborative as possible. Don't just leave people hanging. Define your roadmap publicly if possible. If you're using GitHub, define those in the issues. Tie them to a milestone for the next version. Propose your ideas in public. Get external people engaging and building this community, and you'll build a better project. And with that, we've had a very high-level overview of some of the considerations to take into account when building for developers. Some frameworks and tools to use when planning developer products, a dive into library and API usability, an overview of some specific qualities that you should keep in mind for your developers' customers, some tips on having seamless releases, and lastly, some thoughts on how to engage your community of developers. So I hope this talk provides some pointers for you to think about designing, building great products for developers. Please check out our open source projects at uber.github.io. In addition to Autodispose, we have a lot of others that are well-maintained and provide a lot of awesome features, and we would love more contributors. If this sort of work interests you, then we're hiring. We have offices in the US and in Europe. I'll be around to take questions. I can probably take a few now, but I'll be around after to take any more. Thank you all for attending today.